Hello friends and welcome back to the Automation Nation YouTube channel. In this video, we'll be exploring chapter number 7 of ISTQB Test Automation Engineer syllabus, verifying the test automation solution. So instead of using AI to generate a podcast, this time we'll go through the chapter together, breaking down key concepts step by step. At the end, we'll use Notebook LM to summarize the main points, ensuring we capture the most important takeaways. If you are preparing for ISTQB certification or simply want to deepen your understanding of test automation, don't forget to like and subscribe. So let's get started. So verification of the test automation infrastructure. How to plan to verify the test automation environment including test tool setup. Whether the test automation environment and all the other components of the test automation solution work as expected, it still requires verification. These checks are done, for example, before starting test automation. Steps can be taken to verify the components of the test automation environment. Each of these is explained in more detail below. So test tool, installation, setup, configuration, and customization. Test automation solution is comprised of many components. Each of these needs to be counted on to ensure reliable and repeatable performance. At the core of test automation solution are executable components, corresponding functional libraries, and supporting data and configuration libraries. The process of configuring a test automation solution may range from the use of automated installation scripts to manually placing files in corresponding folders. Test tools, similar to operating systems and other software, regularly have service spokes and may have optional and required add-ins to ensure compatibility with any given system under test environment. Automated installation or copying from a repository has advantages. It can guarantee that tests on a different system under test have been performed on the same version of the system under test, and the same configuration of the task where this is appropriate. Upgrades of the test automation solution can be made through the repository. Repository usage and the process to upgrade of a new version of the test automation solution should be the same as that for standard development tools. Repeatability in setup teardown of the test environment. So a test automation solution will be implemented in a variety of systems, servers, and to support CI/CD pipelines to ensure that the test automation solution works properly in each test environment. It's necessary to have a systematic approach to loading and unloading test automation solution from any given test environment. This is successfully achieved when building and rebuilding test automation solution provides no difference in how it operates within and across multiple test environments. Configuration management components of test automation solution components ensures that a given configuration can be dependently created. Once it is accomplished, documenting the various components that comprise test automation solution will provide the necessary knowledge for the aspects of the test automation solution, for what aspects may be affected or require change when the system under test environment changes. Connectivity with internal and external systems and interfaces. Once test automation solution is installed in a given system under test environment and prior to using the system under test, a set of checks or preconditions should be administered to ensure the connectivity or to internal system, external system, and interfaces are available. So, for example, it is good practice for to log into service, launch test automation tool, verify the test automation tools can access system under test, manually inspect configuration settings, and ensure that permissions are set properly for test logging and test reporting between systems. Establishing preconditions for test automation is essential in ensuring that the test automation solution has been installed and configured correctly. Test automation framework component testing. Just like any software development project, test automation framework components need to be individually tested and verified. This may include functional and non-functional testing. From non-functional, for example, performance, efficiency, and resource utilization. For example, components that provides object verification on UI systems needs to be tested for a wide range of object classes to establish that the object verification functions correctly. Likewise, test logs and test reports should produce accurate information regarding the status of test and automation and system under test behavior. Examples of non-functional testing may include understanding tough performance degradation, utilization of system resources that may indicate defects, such as memory leaks or a lack of interoperability of components with and or outside of test automation framework. The next part is explaining the correct behavior of a given automated test script and or test suite. Automated test suite need to be tested for compliance, consistency, and correct behavior. Different kinds of verification checks can be applied to make sure the automated test suite is available at any given time or to determine that it is fit to use. Steps can be taken to verify automated test suite include check the composition of test suite. Check new tests can focus on new features. Consider the repeatability of tests. Consider the intrusiveness of automated test tools. Each of these is explained in more details below. So, check composition. Check the completeness. Test cases all have expected results and test data is present and for the correct version of test automation framework and the system under test. The next one is verifying new tests that focus on the new features. The first time a new feature of test automation framework is used in test case, it should be verified and monitored closely to make sure that feature is working correctly. Consider the repeatability of tests. When repeating tests, the test solution should always be the same. Having test cases in the test suite which do not give a reliable test result should be moved from the active automated test suite and analyzed separately. For example, due to race conditions, we need to detect root cause. Otherwise, time will be spent repeatedly on these test runs to analyze the same failure. Consider the intrusiveness of automated test tools. The test automation solution will often be tightly coupled with the system under test. This is by design so that there is better compatibility as it pertains to the level of interactions. However, this close integration can also lead to adverse outcomes. For instance, when the test automation solution is located within the system under test environment, system under test functionality may differ from when tests are conducted manually, potentially impacting performance as well. A high level of intrusion can show failures during testing that are not evident in production. If this causes failures with the automated tests, the confidence in the test automation solution can drop dramatically. Developers may require that failures identified by test automation be reported manually, if possible, to assist with the analysis. The next part, let's talk about unexpected results. Identify where test automation produces unexpected results. When test script fails to or passes unexpectedly, root cause analysis must be performed. This will include inspecting test logs, performance data, setup, and teardown of test script. It is helpful to execute a few isolated tests. Intermittent failures are more difficult to analyze. The defect can be in test case, test in the system under test, in test automation framework, hardware, or the network. Monitoring system resources may yield clues for the root cause. So, test log file analysis of the test case, the system under test, and the test automation framework can help identify the root cause of the defect. Debugging may also be necessary. To aid in identifying the root cause may require support from a test analyst, business analyst, developer, or system engineer. Verify if all the assertions are in place. Missing assertions may result in inconclusive test results. The next part is explaining how static analysis can aid test automation code quality. Static code analysis can help find vulnerabilities and defects in program code. These include the system under test or test automation framework. Automated scans can inspect code to mitigate risks. This provides a review of the system-wide tests for defects and ensures code quality standards are being met and applied. This can also be considered a proactive defect detection technique, and this plays a significant role in DevSecOps implementations. For example, DevOps with emphasis on security. These scans occur early in the CDLC via pipelines to provide development teams with immediate feedback. The output regarding defects is usually categorized as critical, high or medium, or low severity. So there are 4 types of severity: critical, high, medium, or low. So the development team has the ability to prioritize which defects they choose to fix. Certain static analysis tools have the ability to provide suggested code fixes to address the defects they found. So it will present development teams with a copy of the following lines of code and offer a possible remedy for developers to implement. Additionally, these tools aid test automation engineers by measuring quality, suggesting areas where to comment code, improving code design for optimized resource handling. For example, utilizing try-catch blocks and better looping structures and removing poor library calls. As test automation tools use programming languages, there is a risk that inadequate test automation code can be introduced to the CDLC, software development lifecycle. As a simple example, a common practice when automating tests is to have a username and password. It is conceivable that test automation engineer can incorrectly include the password in plain text with one or many test scripts. Static analysis tool can benefit test automation code. They can be used to analyze test automation code for security violations, such as plain text password within the code. Static analysis tools support many programming languages, including those used by test automation software. Therefore, it is imperative that test automation engineer extends the best practices of scanning code to also include test automation code. Even through the test automation code, it's not necessary deployed with the overall software. There are clearly potential vulnerabilities if the password was discovered in the accompanying automation test script. So that's it. Let's move on and ask to summarize, for example, the first chapter. So we've read about test tool installation, setup, configuration, and customization, ensuring that executable components, function libraries, and supporting data configuration files are correctly set up. So automated installation or copying from the repository is advantageous as it guarantees consistency across different system under tests and allows for easy upgrades. Repeatability in setup teardown, a systematic approach to loading and unloading the test automation solution from any test environment is necessary to ensure proper functioning across different environments. Configuration management of TAS components ensures dependable creation of a given configuration. Connectivity with internal and external systems. Also, we talked about prior to using system under test, checks should be performed to ensure connectivity to internal and external systems and interfaces. And let's dive deep into the next part. Explain correct behavior. So, provide short summary on this part. So to ensure the correct behavior of automated test scripts and suits, they need to be tested for completeness, consistency, and correctness. Key steps to verify automated test suite. Checking composition of test suite involves ensuring components, test cases have expected results and test data, and verifying the correct version of test environment, test automation framework, and system under test. Refine new tests that focus on new features. And considering the repeatability of tests, test results should be consistent. When they are repeated, unreliable test cases should be removed from active automated test suite and analyzed to find the root cause. Considering the intrusiveness of automated test tools, close integration of the test automation solution with the system under test can lead to different system under test functionality compared to manual testing, potentially impacting performance. High intrusion levels can cause failures during testing that are not evident in production, reducing confidence in the test automation solution. So developers may need to manually reproduce failures identified by test automation to aid in analysis. And the next part, let's talk about unexpected results. That's really easy. The next part, explain how static analysis can aid. So generate small summary. Small, maybe I would say generate in a few words. So static analysis can aid test automation code quality by finding vulnerabilities and defects in program code, including the system under test or the test automation framework. Automated scans can inspect code to mitigate risks, review for defects, and ensure code quality standards are met, serving as proactive defect detection technique. Static analysis tools can benefit test automation code by analyzing it for security violations, such as plain text passwords, and can support many programming languages used by test automation software. So that's basically it. We've covered the whole chapter 7. Thank you for your attention and your patience, and feel free to subscribe and like this video, and see you again later. Bye!